Okay, in this video, we are going to talk about ratios and proportions. There is two different sheets. Well, it's technically one length, but it has two different sheets on it. You're going to need these sheets for the notes today, and they are on week 5 under documents. So if you want to print those out, or if you just want to pull those up when we get to those in the video. Okay, so we're going to talk about ratios and proportions. A ratio is just a comparison between two values. Okay, so a comparison between two values. These two values could be lots of different things, and you probably have had a lot of experience with ratios before. Sometimes these ratios can be written as a fraction, not always though, okay? So we will talk about when we can do that in just a second. So it sometimes can be written as a fraction. Okay, so there are 3 different types of ratios, and if you've already read from the textbook, you have already seen these 3 different types of ratios. The first type of ratio is a part-to-part ratio. So part-to-part ratio. Sorry, having a hard time writing today. So part-to-part ratio. So an example of a part-to-part ratio would be if we were talking about like the number of girls in the classroom versus the number of boys in the classroom. So let's say there are 2 girls for every 3 boys in a classroom. Okay, that's an example of a part-to-part ratio because the girls are apart and the boys are apart. We're not talking about a whole here at all. Okay, so the best format for writing that ratio would be using your colon. So 2 girls to every 3 boys. Okay, we could not write this as the fraction of 2/3 because a fraction needs to be a part over a whole, and the whole is not 3. Okay, you can still write this as a fraction, and again, if you've read from the textbook, you've already seen this. The way we could write this as a fraction would be there's 2 girls for every 5 boys, or not, sorry, for every 5 students in the classroom, because 2 and 3 makes 5. So you could write it as 2/5, 2 girls for every 5 total students. You could also write it as 3/5 because it's 3 boys to every 5 total students. Okay, so that's one way you could do it. Just know that you can't use these specific numbers, the 2 and the 3, to write a fraction in a part-to-part ratio. The second type of ratio that we see is a part-to-whole ratio. So a part-to-whole ratio, I'm going to use the same example, but I'm going to change it to part-to-whole ratio, would be, we kind of already wrote this, but there are 2 girls for every 5 students. In a classroom. Okay, so the way you could write the format choices for this one, again, you can use the colon. It would be 2 out of 5. And then this one, you can just use the numbers from the problem to write the fraction. So it would be 2/5. Okay. The third type of ratio would be a whole-to-whole ratio. And again, if you've already read the textbook pages, you've already seen this. So this is a whole-to-whole ratio. Okay, so a whole-to-whole ratio, an example would be, I can drive 25 miles per every 1 gallon of gasoline in my car. Okay, the reason why this is considered a whole-to-whole ratio, 25 miles is a whole. 1 gallon is a whole. It's not a part of a different situation. So this is a whole compared to a whole. This is a situation where you would not use a fraction for this because it doesn't really make sense because the units are different, the miles and gallon. Okay, so this is actually called a rate, and this specific one is a unit rate, and we'll talk about that a little bit more. So a rate is when you have two different measurement types. So we're comparing two different measurement types. Okay, before girls and boys in a classroom, those are both students that we were comparing. Girls and students in the classroom, those are all students we're comparing. Here, miles and gallons, that's two completely different measurements. And so that's the reason why we see this written as not that one. Sometimes you see it MPG, miles per gallon. Another one you've probably seen pretty often is miles per hour. How many miles can you drive every hour? We can also, another common one is like words per minute. If you're like talking about typing, how many words per minute can you type? Okay. Or if you're teaching specifically first grade, second grade, you're going to be doing lots of testing with your students and seeing how fast they can read. So how many words per minute can you read? Okay, so that's an example of a whole-to-whole ratio, and in this one you do not use fractions at all. This one you just use the colon, or you'd write it out like 25 miles for every 1 gallon. Okay, so if you will get up, pull out, however you have it, this paper right here. What I want you to do is I want you to pause the video in just a second. I want you to try this on your own and then resume the video and you'll see we're going to go over this together. Okay, so I want you to read the situation and decide, is it a ratio? Is it a fraction? Is it both of them? And you may have, I was gonna say you may have multiple answers. Both would obviously be both answers here. So pause the video here, see how far you can get on this worksheet. If it's confusing, don't worry about it. Just come back and we'll go over it as soon as you resume the video. Okay, so you are back from doing this worksheet. So let's go through this and make sure that you did this correctly and talk about it if you didn't do it correctly. Okay, so the first one we're going to talk about is number 1, there are 9 women for every 2 men in this class. Okay, so this is a ratio, right? 9 women for every 2 men. What type of ratio is this? This is a part to part. Okay, so would you write these two numbers as a fraction? 9 over 2 or 2 over 9? No, you would not write it as a fraction. Could we change the problem and write it as a fraction? Yes, you could change it into 9 women for every 11 people in the class. But in this specific situation with these two specific numbers, you can't write this as a fraction. Okay, you're not going to be, never mind, I'll talk about that. Okay, look at number 2. 2 out of every 5 students in this class claim to be middle school teachers. Is that a ratio? 2 students to every 5 students? Yes, it's a ratio, okay? Is this a fraction? 2 out of 5, could I write that as 2/5? Yes, because this is a part to whole situation. So this would be a fraction, so that would be both in this case. Okay, look at number 3. Brand A orange juice costs 7 cents per ounce. Brand B costs 6.5 cents per ounce. Okay, so is this a ratio? Yes, we're talking about how much orange juice costs per ounce. So money per ounce. So yes, it's a ratio. Is it a fraction? Can I write this as 7 cents over 1 ounce? Is it a part over a whole? No, it's not. It's 2 completely different measurements. This is the whole to whole ratio. So this is the 7 cents to 1 ounce. You couldn't write it as 7 over 1 or 6.5 over 1. Okay, so this is not a fraction, so it is not both. It's just a ratio. Okay, and again, remember we talked about the whole to whole ratios. Those are the ones that are rates. Okay, look at number 4. 1/4 of the marbles in the jar are blue. Okay, so is this a ratio? Do we know how many marbles per how many marbles is blue? It says 1/4. That means 1 out of every 4 marbles is blue. So it is a ratio. It actually told us the situation as a fraction, so we know it's a fraction, and so it's both in this case. Number 5, my average speed while driving to work was 35 miles per hour. Is this a ratio? Is it part to part to whole, or whole to whole? Here, 35 miles for every 1 hour, that's a whole to whole ratio. This one is also a rate. So it's just a ratio. I cannot write it as a fraction, so it is not both. Okay, look at number 6. Jane drank 3/4 a cup of milk. Is this a ratio? That 3/4, obviously it's a fraction, okay, but is it a ratio? What does the 3 represent and what does the 4 represent? If you tried to like think about this and figure it out, like it doesn't represent anything. It's just literally a fraction. We're not comparing two different quantities here. We're just telling how much she drank. That's just one quantity. So it's no part to whole or part to part or whole to whole. So this is not a ratio. It's just a plain old fraction telling how much of a cup she drank. Okay. And look at number 7. According to the Kool-Aid directions, for each quart of water, you should add 1 scoop of Kool-Aid and 2 scoops of sugar. Okay, so the ratio here is 1 scoop of Kool-Aid to 2 scoops of sugar. Is this a ratio? Is it a fraction? Is it both? So we're looking 1 scoop of Kool-Aid for every 2 scoops of sugar. Okay, so that would be, depending on how you think of the problem, technically you can think of this as a part to part or a whole to whole. If you thought of it as a part to part, you're thinking about, I'm adding 3 scoops of things. 1 of those scoops is Kool-Aid and 2 of those scoops is sugar. Okay, so it is a ratio because I'm comparing those 2 quantities, 1 scoop of Kool-Aid, 2 scoops of sugar. So for sure a ratio. If you wanted to write this as a fraction, if you thought about it as a part to part ratio as a fraction, you would say 1 scoops out of every 3 scoops total that I add. 1 scoop is Kool-Aid out of every 3 scoops, or 2 scoops of sugar out of every 3 scoops. You could also, I would say you could also consider this a whole to whole fraction because it's like 2 different things I'm comparing. It's Kool-Aid versus sugar, and that would work also. And technically that's the rate that you're adding it in if you wanted to think about it that way. It's kind of weird for this problem, but you could technically. So I would not write this as a fraction with the 1 and the 2. I wouldn't say 1/2 is Kool-Aid versus 2, I don't know, that wouldn't even make sense. Okay, so it's not a fraction, so it's not both. Okay, I hope that helped kind of talk about the difference specifically between a number that's just a plain old fraction versus a fraction that is actually a ratio, that the 1 means something and the 4 means something, versus here where the 3 didn't mean anything and the 4 meant something. Okay, so we're gonna go back to our notes and we're gonna talk about proportions. So that's the gist of ratios. Now let's talk a little bit about proportions. Okay, so a proportion is 2 ratios that reduce to the same common fraction. So 2 ratios that reduce to the same common fraction. So for example, we just finished with fractions and decimals. 5/10 is the same equivalent fraction as 3/6. So 5/10 is proportional to 3/6. Okay, so now I want you to go to the back of that fraction paper. This is table 8. We're going to look at this. If you were in class, we would probably get out some counters and use it here. We're not going to do that, obviously, since you don't have those at home, but it's kind of drawn out here for you. So it says, use the information in the table to find how the number of blue cubes compares to the number of green cubes. And you could use it out, and we're just going to fill in the table. Okay, so we can draw squares or you can just write it in. It's up to you. Okay, so it tells us, the second column tells us the information we need to know, and we're going to use the second column to fill in the first, third, fourth, and fifth columns. Okay, so there are 4 blue cubes for every 6 green cubes. Okay, so it's kind of like if you wanted to think about it, there's a couple different ways you could think about it, but you could think about it as a fraction if you wanted to, if that was helpful. You could think about it as a fraction. You could also think about it as like groups if you wanted to. So you could think about here, I only have 1 part here. Well, it's like I have 1 part here like that. So if you wanted to think about this was 1 part and this was 1 part, I have a total of 2 parts here. Okay, so then I'm putting them in groups of 2. So this is a total of 3 parts, if you wanted to think about it like that. You can also think about it as 4 blues to every 6 greens. If there's 4 blues to every 6 greens, how many, and there's 2 blues here, how many greens would need to be here? Okay, so if there's 2 parts here and 3 parts here, you could think about this as, this is double of that, right? To get from here to here, it's like I multiplied by 2. Okay, so to go from here to here, it's like I would multiply by 2 also. So 4 divided by 2 is 2, and 6 divided by 2 is 3. And these would be green blocks down here. Okay. So again, 2 parts here to 3 parts here. I have 2 parts here to 3 parts here. So this is like the equivalent fraction. 4, 6, there's 4 blue and 6 green, reduces down to 2/3, 2 blues and 3 greens. Okay, so if I'm going up to the next one, this has 1, 2, 3, 4, 5, 6 blues now. To figure out how many greens that I have, it might be kind of difficult to look at it from here to here. Like if I had 4 blues, now I'm going up 6 blues. I can't think about this as like adding 2 blue blocks here, because that wouldn't be a proportional or a ratio technically. Okay, so I need to think about it as, if you think about the parts, if you want to, the way I split this into 2 parts, there was 1 in each group. The way I split this into 2 parts, there were 2 blocks in each group. If I split this into 2 parts, there would be 3 blocks in each group. Okay, so again, 3 parts, 3 parts, 3 parts. I need to draw 3 parts here. And again, there are 3 blocks in each group. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And those are all green ones here, obviously. Okay, so for every 6 blues, there are 9 greens. Okay, another way you could think about this is the fraction 2/3. If I wanted to get 6 out of, figure out how many here, the way I get from 2 to 6 is by multiplying by 3. So 3 times 3 is 9. So comparing it back to an equivalent fraction is sometimes helpful. Okay, here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15 green blocks here. There's 15 green blocks here. How many blue blocks would we need? So I want you to pause the video for a second and see if you can figure out how many blue blocks you would need. Okay, so a couple ways to do it. One way to do it is to split the bottom into 3 parts. So here's 1 part, here's 2 parts, here's 3 parts. Okay, there are 5 blocks in each group. So if I wanted to put my 2 parts up here, I would need to put 5 blues in each group. Okay, so the answer for this part is 10 blue blocks. Is the ratio 10 blue to 15 green. Another way you could have done it is compare it back to that original fraction of 2/3, 2 to 3. Okay, so, let me do this one first. To get from 3 to 15, it's like multiplying by 5. To get from 2 to here, I need to multiply by 5 also, and 2 times 5 is 10. Okay, and the last one, 50 blue to how many green? So you could think about it in your head, 50 blue blocks. If I split it into 2 parts, how many are in each part? Well, there's 25 blue here and 25 blue here. So for the green, again, it's 2 parts to 3 parts. So there needs to be 3 parts here, and there's going to be 25 green in each of those, which would be a total of 75 green blocks there. Okay, again, if you wanted to do it with your fraction, you would think starting off with 2, how do I get to 25? Sorry, how do I get to 50? I multiply by 25. So same thing here. Take my 3, multiply it by 25 to get 50. Okay, so looking at that, I hope that you can see that ratios are, or proportions, to compare proportions, we are multiplying by a number. You can't look at this and say, well, I have 2 blocks here and 2 blocks here, so I just need to add 2 to the top and add 2 to the bottom. Okay, that is a common student mistake, and it does not work because it will not give you an equivalent fraction that way. Same thing here. I had 2 blue blocks here and I have 6 blue blocks here. It's a multiple of 3. It's 3 times as big, not I added 4 blocks, because if you add 4 blocks here, you're not going to get the correct answer. Okay, so to take a ratio and extend it to a different situation, you have to multiply by a number every time, no matter what, forever and ever. Okay, so we can talk about a couple different ways to solve a proportion. Okay, so let's move into that. There are 2 different ways to solve a proportion. Or 2 different ways we're going to use in this class. The first way is a table. And the second way is to use X as an unknown. And we're going to solve them the same way here. Okay, so let's get our first problem. If, for example, we said the problem was the ratio of men to women in this class is 2 men to every 18 women in a class. If this ratio is proportional of men to women at the university, how many women would you expect for 628 men? Okay, so that is the problem. We're going to solve it. I'm going to show it 2 different ways. The first way we're going to show it is with a table. Okay, so with the table, I have 2 different things. I know men and I know women. So in the classroom, there are 2 males for every 18 females. Okay, so then at the university level, it's asking how many women, that's what I'm looking for every 600, or if there are a total of 628 men. Okay, so a lot of times whenever you do these problems, you do like the cross multiply and solve for X. And that is a great way to solve proportions, especially whenever they aren't super perfect proportions to start off with. The issue is, and the reason why we're not going to do that right now, we will later, but right now we're going to just use proportional reasoning to figure this out, because usually when you're teaching this topic, you're in 4th grade and 5th grade, and they haven't learned algebra to solve for X yet at that point. So we're going to focus on proportional reasoning at this point to figure out what this number is. So if I know that the ratio 2 to 18 is a true ratio and it works for this problem, and I know that 628 is my final number I'm trying to get to, what I can do is figure out, what do I multiply by here to get from 2 to 628? Well, one way you can figure that out is by using your calculator and doing 628 divided by 2 is 314. So I multiply by 314 to get to 628. Okay, so this is a proportion that's 314 times as big, or this is a ratio that is 314 times as big as your original ratio. So to figure out the women, I just need to multiply by the same value, 314. So when I type that in my calculator, 18 times 314 is 5,652 women. Okay, so that is the way to solve it using a table. If you wanted to use just a proportion to do it, we are going to do it with the same proportional reasoning. So again, they gave me the information that 2 males to every 18 females. So we're going to say 2 males to every 18 females. And that fraction, or that ratio, is equivalent to the ratio of 628 males to how many females here? Okay. And again, if you put an X here, you could cross multiply and solve. But again, remember, these students haven't quite learned algebra at this point. So we're going to use proportional reasoning. 2 times what gives me 628? Well, 2 times 314. So do the same thing on the bottom. 18 times 314 is, again, the same number, 5,652 females. Okay. So that's how I want you to do your homework. Anytime that you have to do a ratio or proportion, for this part, you are going to either use a table or proportion, but I want you to use proportional reasoning, the multiplying by a number, instead of actually like solving for X, essentially. Okay, so we're going to do another couple problems. This first problem, I'm going to give you one ratio, and then we're going to find a lot of different things. Okay, so if we had the information that flowers cost $11 per dozen. Okay, so for part A, we want to find the cost of 3 dozen flowers. Okay, so to find the cost of 3 dozen flowers, let's use a table here. So my table here is cost per dozen, because that's what the information told me. I was told it cost $11 for every 1 dozen of flowers. So for this problem, I want to figure out how much does it cost for 3 dozen flowers. So 1 times what equals 3? Well, 1 times 3 is 3. So I have to multiply by the same factor on top. 11 times 3 is $33. How much do I have a dollar something? Okay. Let's do the same thing, but this time let's find the cost of 60 flowers. So the cost of 60 flowers, this time when we make our table, instead of thinking about it as cost per dozen, let's think about it as cost per flower. Okay, and you might say, I don't know how much 1 flower is. You're right, we don't, but we know that $11 is how much it costs for 12 flowers. So if it costs $11 for 12 flowers, a dozen of flowers, I'm looking to figure out how much does it cost for 60 flowers. And again, I can use proportional reasoning here. What factor do we multiply 12 by to get 60? We multiply by a factor of 5. So I have to do the same thing on top. Multiply by a factor of 5. And 5 times 11 is $55. Okay. Let's do one more problem, and then we're going to talk about some mistakes, and we're also going to talk about some unit rates. Okay. So a committee must have a ratio of 3 males to 4 females if the committee has 28 total members how many are female? Okay, so we were given that there are 3 males for every 4 females. Okay, so since we were told there were 3 males for every 4 females, and we're asked how many females are there for 28 total members, if you try to set it up like this, how many females for every 28 total members, it's not going to work out here. Well, first of all, 3 times something isn't 28, like it's a decimal, it's kind of a mess. But also notice I have males to females, but I have total members to females here. So I'm not, this isn't proportional. I'm not comparing 2 ratios that have the same numbers on, or the same measurements on top and on bottom. So this is not the way to do the problem. Instead, if I want to do total members and females, I would need to think about it as females. You can put females on top or on bottom. I'm going to put it on top. But females to total members. Okay, so the ratio of 3 males to 4 females, there are 4 females for how many total members? Well, 3 plus 4 is 7. So that's the original ratio that you use. I'm looking for how many females for 28 total members. And that's a much easier problem to do where you can actually do it. 7 times 4 is 28, so I need to multiply by 4 on top also, and that is 16 females. Okay, so I hope that is helpful with some of the problems. What if I take that problem and extend it and I say, for that same problem, there are 20 females interested in being on the committee, but only 6 males. How many more males do we need to make this work? To keep the ratio, the correct ratio. Okay, so this is the one, we're looking for males, they told me females. This is one where I can use the part-to-part ratio. Okay, so I was told it's 3 males for every 4 females. That's the ratio I need. I have 20 females. They told me I have 6 males already and I need to figure out how many more I need. So let's not put 6 here. Let's figure out what this number needs to be and we can just take off 6 at the end. Okay, so again, find your factor. 4 times 5 equals 20. So 3 times 5, I need 15 males. Okay, so 15 males is how many I need. I already have 6, and 15 minus 6 is, we need 9 more males to make the ratio stay the same. Okay, so notice on all these problems, we are either setting up a table or we are setting up a proportion with like a fraction on one side and a fraction on the other side, but we are not cross multiplying and solving for x. On all of these problems, you are finding the factor it takes to get to the other ratio and multiplying by that number on bottom and on top. Okay, so the last thing, actually the 2 more things. Let's talk about the common mistakes for students. So a common mistake for students is, if I had some situation where I had 1/2 as a ratio, excuse me, and I was trying to figure out 5 out of how many here? For this specific one, it's pretty simple because 1/2 is a fraction or a ratio that a lot of people are super, like have a lot of knowledge about or very comfortable with. But a common mistake here is to say, well, how did I get from 1 to 5? Well, I added 4. So let me add 4 on bottom. If you add 4 on bottom, 2 plus 4 is 6. Is 5 6 the same thing as 1/2? No, it's not. Okay. So just make sure you're always multiplying and you're emphasizing the multiplication here with proportions. It's a multiple of a ratio. It's not adding a number on top and adding a number on bottom. The other thing I want to talk about is unit rates. We talked about rates at the beginning. A unit rate is a rate that, let's see, if you look at the other paper that was posted on the documents, we're going to look at this page. So we're going to start with 6.1, page 170, unit pricing. A unit rate is like a unit price, is a very, very common thing. You see this at the grocery store. Sometimes it's not super helpful, but you see it at the grocery store. It's underneath the price. So say like, here's an example, 24-ounce jar of pickles costs $2.79 and the unit price is 11.6 cents. So that means that the pickles cost 11.6 cents per ounce, which is equivalent to 11.6 cents is written like that per ounce. Okay, so let's kind of talk about that real fast, the unit rate. So unit rate or unit pricing is price per, it depends on what you're given. It's usually price per ounce, okay? So the way that they found that 11.6 cents is it's a 24-ounce jar of pickles. And the 24-ounce jar of pickles costs, it told us $2.79. So to find the price per ounce, I want to put the price on top and the number of ounces on bottom. So $2.79 divided by how many ounces there are, 24 ounces. And when you type that in your calculator, $2.79 divided by 24 ounces gives you that decimal. So this is 0.11625 technically, but if we rounded it to 6, this right here, we usually only view dollars and cents as 2 decimals, so that's 11 cents. So that's why it's 11.6 cents. The reason why we go ahead and use this third decimal, the thousandth place, is because what if I had a jar of pickles? Let's see if it has. Sorry, I was looking to see if I had a specific problem here. What if it was, I'm just going to make it up. What if we said it was, there was another brand, a different brand. So let's say this is like the Walmart brand, the Great Value brand, and this one's like in Classic brand of pickles. Let's say that was a 28-ounce jar of pickles, and that cost, let me see, let me do the math real fast. What if that cost $3.30? Okay, so let's figure out the price per ounce for this one. Again, it's price divided by the number of ounces there are. So if I did $3.30 divided by, this time it's a 28-ounce jar. Okay, so when I divide it, 330 divided by 28, this one is 0.1178, so on and so forth. So this is 11.7 cents per ounce. Okay, so if you rounded it up here at all, you would have like 12 cents and 12 cents. Which one's actually more expensive though? This brand is more expensive, okay? And it's not by much, it's just by a little bit, but say you were buying pickles for, 1,000 people, like that would start adding up at the end. So you would for sure want to get the cheaper one. So unit rate is a way to, again, compare two items and see which one's the cheaper item, especially when it's hard to compare, because 24-ounce jar and a 28-ounce jar, this price difference isn't that much different. It makes sense that this one's going to cost more because you get more ounces out of it, but the price per ounce or the unit rate tells us how much each of them cost per ounce, and then we can compare and see which one's the better buy. Okay, so that's unit rate. Sometimes at the grocery store this doesn't help out because like I wish I had a picture or something, a specific example, but sometimes like if you go to buy a box of macaroni, it says the macaroni costs $2.50 per box and the price per, the unit price is $2.50 per box, and it's like, well, that didn't help me at all. But there is actually another way to do this. Unit rate can be done as price per ounce, and this is the way I always tend to do it, but you can also flip your ratio here. We could do the ounce per price here, okay? So I believe this is on the back here. Let's see. Oh, actually, it's right here on the bottom. So it says that, if you read this part, we kind of just talked about this. Many states now require grocery stores to show the unit price below each item. One of the reasons for this law is people tend to believe that larger items are proportionally cheaper. For example, they believe the 64-ounce box of detergent will cost less than twice as much as the 32-ounce box. And companies use this belief to their advantage, and they start charging more for the bigger box just to make you buy more and pay more money. So it's good to know about the price per ounce. So in this situation, it says, let's say you have Paul Bunyan pancake mixes in 2 sizes. We have the 30-ounce box and the 50-ounce box. Smaller box is $2.89, the bigger box is $4.69. Let's figure out which one is the better buy. Okay, so actually, if you go ahead and pause this and do the price per ounce and figure out which one's the better buy, the smaller box or the larger box, and come back when you have that finished. Okay, so I'm working this out now. The smaller box versus the larger box. The smaller box tells us that we have a 30-ounce box, and it cost us $2.89, where the larger box is 50 ounces and it cost $4.69. So the price per ounce here would be $2.89 divided by 30. When I type that in my calculator, I get, 2.89 divided by 30. I get this as 0.96, sorry, 0.096. So it's 9.6 cents per ounce. Same thing over here, price per ounce, $4.69 for 50 ounces. So $4.69 divided by 50 would give me 0.938. Sorry, 0.0938, which is 9.4 cents per ounce. Which one is cheaper? This one's cheaper because I'm only paying 9.4 cents for every ounce versus the smaller one, I'm paying 9.6 cents for every ounce. So in this case, the larger one is cheaper. Not always the case, but in this case it is. Okay, part C, it says Jackie did the problem this way. She switched her fractions. She did 30 divided by the price and 50 divided by the price. Okay, so let's do the same problem, but let's flip our fractions. 30 divided by the price of $2.89. When you do that, you get 10.38. Okay, so this is kind of hard to, lots of people do this math when you're figuring out how much like the unit rate is. The issue is, what does this mean? 10.38, 10.38 what? Well, if you think about it as over 1, this says I get 10.38 ounces, because remember this is ounces, for every dollar that I spend. Okay, so for the smaller one, you're getting 10.38 ounces for every dollar that you spend. If I flip this one, 50 divided by 4.69, you get 10.66 ounces for every $1 that you spend. So which one's the better buy? The one that you're getting more ounces for every dollar. So the larger one's obviously still the better buy. It does not matter which way you do these unit rate problems. You can do them price per ounce or ounce, how many ounces you get for $1. You just need to be aware of which way you do it, because if you're comparing these two, you're looking for the smaller number. If you're comparing it this way, you're looking for the bigger number, because we want more ounces per dollar. Here, we want less money per ounce. Okay, I hope that wasn't confusing. I hope that that's helpful and might shed a little light on the unit rate idea. Okay, so if you have any questions about this lecture, feel free to let me know what questions you have. And your homework is posted for week 5, and it'll be due on Sunday at midnight.